Okay, to continue with our lesson for Monday today, our new section that we'll be learning, we have 2 more sections to learn before our test. Our new section that we'll be learning is 6.7. It's page 9 of your note packet. This section has 4 test questions. That's a lot of test questions for one section. 4 test questions, and I think they're like 4 to 6 points each. So this is a huge, important section. So you want to make sure you spend a good amount of time on the homework on this. So this section is solving radical equations. So a radical equation is just an equation that contains a radical. You can see all of these are equations that contain a radical. So to solve a radical equation, our goal is to eliminate the radical. So we want to get rid of the radical so that we can solve for x. I don't want to solve for square root x. I don't want to know what square root x is. I want to know what x is. And we do that by raising both sides of the equation to a power equal to the index. So if the index is 2, remember there's an imaginary 2 there, we square both sides. If the index were 3, we would cube both sides. So it's a very easy process. The problems get quite a bit harder as we go, but the basis is to undo a radical, you just raise it to the power of the index. The unfortunate thing about radicals, whenever there's an even index, 2, 4, 6, it can pick up extra solutions that don't check. So every single even index problem, whenever you're solving a radical equation, every single even index does have to be checked. So once you get the answer, you plug it back in. I'll show you here how to check it. But it's not a question of, I don't have time to check. You have to check it. And I will put one on the test where the one, or maybe there's 2 solutions and one doesn't check, or maybe there's 1 solution and it doesn't check. So I will hold you accountable for checking. So make sure that you check each of these as we go. So step number 1 is we have to isolate the radical. On both of these problems, you can see the radical is already isolated. Nothing else is on that side but the radical and what's under it. So I say, oh, this is an index of 2, so I'm going to square both sides. Well, a square and a square root undo each other. They cancel each other. They're opposite operations, so you can think of this as just going away. So then I end up with x. When I square 3, I get 9. So to do the check, I go into the original equation. I put 9 in for x. Is the square root of 9 equal to 3? Yes. 3 equals 3. So that one's good. So we can go back and show the reader that 9 is the valid solution. So this is called a potential solution. Once you check it, then it's actually a valid solution for that equation. So now let's look at one that doesn't check. Square root's isolated, so it's a square root again, so I'm going to raise both sides to the power of 2 because I want to undo that square root. So again, these cancel each other, and I get x equals -4 times -4, 16. So that is right now called a potential solution. So to check it out, I put it into the original, so put 16 in for x. Is square root of 16 equal to -4? No. 4 does not equal -4. Therefore, we can either write an empty solution set or we can write no solution. And that's because we know the square root of 16 is positive 4, because this tells me only to take the positive answers. So let's review the steps before we practice these. So this is super important. Highlight it, bubble it. This has to be the first step. Step 1, because you can't do any of the future steps unless the radical's isolated. So that means you want only the radical on the left-hand side. So look at example 1 below. See how the radical is all by itself? There's no numbers outside. Same thing with example 2. The radical's all by itself. There's no numbers outside. So they're both ready to go. Then we raise each side to the power of the index. So this is a square root, so I'm going to square both sides. This is a square root, so I'm going to square both sides. And notice you only put one square on the left and one square on the right. You don't square every term. It says square both sides. So one square over here, one square there, and so on. Solve the resulting equation after you've squared both sides. And then, of course, if it's an even index, let's write that down here. Even indices must be checked. So an index of 2, 4, 6, they have to be checked. The odd indices, great idea to check it. Check your work, make sure you get it right, but they don't pick up the extraneous solutions that the even indices do. So remember that vocabulary from before. If we have an apparent solution that doesn't check, it is then called an extraneous solution. So let's practice these steps down here. So step number 1, isolate the radical, done. Step 2, raise it to the power of the index. The index is 2, so notice I'm raising both sides to the second power. The index and the radical undo each other, so this just pops out as 2x plus 1. And over here I get 5 squared, 25. Then I subtract 1 from both sides, and I get 2x equals 24. And then I divide both sides by 2, and I get x equals 12. And the check is on the other side of the paper, which is kind of a bummer. So let's just go ahead and check here, because it's kind of hard to look back at the original problem when they're on separate pages. So write the original problem, just like you see it from the get-go. Then plug in your potential solution, which is 12. So we're going to plug in 12 for x. And so we want to know, does 2 times 12 plus 1 give us 5? So 24 plus 1 is 25. And that is a true statement. Boom. So then we go back, since we've proven that it is an actual solution, we show the reader that it checks by putting it in solution sets. Okay, now let's try the next problem. It's a little bit more rigorous. You're going to see this is more like what I put on the test. In fact, I did put this one on the test, so this is a good one to highlight as a test question. And if you want to mark it in your packet, it looks like number 21 on your practice test. It's also number 21 on the test, just FYI. Okay, so following the same steps listed above, first we isolate the radical. Yep, the radical's all by itself, no numbers outside. Second, we raise both sides to the power of the index. The index is 2, so we're going to square both sides. So on this side, the radical and the square just undo each other, and we just get what's under the radical, 6x plus 1. But on this side, and this was a very highly missed problem in chapter 4. So x minus 1 squared doesn't mean x squared plus 1. You'll get every one of these incorrect if you think that's true. This means x minus 1 times x minus 1. So this is a FOIL problem. So from FOILing we get x squared from f. From outer we get negative 1x. From inner we get negative 1x. And from L we get plus 1. And that's where they got this. X squared minus 2x plus 1. Now we have no radical, which is awesome, but you're going to have to think back to chapter 4 again. So anytime you see a term with a squared, that's your hint. This needs to be set equal to 0. So the minute you see that, and we didn't have it over here, notice there were no squares over here, but here we do, that means this equation needs to be set equal to 0. So we had problems like this on our last test, and we also had problems like this on our first test. So x squared tells us it needs to be set equal to 0 so that we can factor. So when you subtract 6x to bring it over so you can get 0, and then you're going to subtract 1 to bring it over so you have 0 there on the left. So now those cancel, so we have 0 equals x squared, negative 2x and negative 6x is negative 8x, and then the plus 1 minus 1 also cancel. So this is what we have, 0 equals x squared minus 8x. This problem was also on your chapter 4 test. Whenever we have two terms, first we're supposed to think GCF, see the x common, so take the x out. When you divide each of these terms by x, in parentheses you get x minus 8 equals 0. Then you have to set each one equal to 0, x equals 0, x minus 8 equals 0, because the zero factor property says if a times b equals 0, then either a is 0 or b is 0. And then when we solve this, we get x equals 8. As you can see, those are our two potential solutions, x equals 0 or x equals 8. So now let's turn the page and copy this problem over at the top of page 10. So right at the top of page 10, let's write this problem down. I have a separate sheet so I can see. So here's the original problem, square root 6x plus 1 equals x minus 1. And we already did this check, so you don't need to look over here. So here's our new problem, and we got two values. We got x equals 0 or x equals 8. Those were our two potential solutions. So here's the check for both. First we're going to put 0 there. So 6 times 0 plus 1, does that equal, so first we have to put 0 in, 0 here and 0 here, does that equal 0 minus 1? Well, 6 times 0 is 0, plus 1 is the square root of 1. 0 minus 1 is negative 1. Does the square root of 1 equal negative 1? No, it does not. So that means 0 is an extraneous solution because it doesn't check. It provides a false statement. Then we put 8 in. So change those zeros to 8s. Sometimes both will check, sometimes both will not check, sometimes just one will not check. So you always have to check both solutions if you get two of them. So now we're putting 8 in. 6 times 8 plus 1. Is that equal to 8 minus 1? So 48 plus 1 is the square root of 49. 8 minus 1 is 7. That's a true statement. 7 equals 7. Therefore, we can say 8 is a valid solution. So we just put the valid solution in solution sets to show the reader there's only one solution. 0 is extraneous, 8 is the valid solution.